हेलो दोस्तों, स्वागत है आपका मेरे यूट्यूब चैनल हैप्पी लर्निंग अवर्स में। मैं ऋषभ आपका इस इसरो प्रीवियस ईयर क्वेश्चन वीडियो सीरीज़ में स्वागत करता हूँ। हम अभी मटेरियल साइंस और मेटलर्जी सब्जेक्ट्स रिलेटेड जो भी प्रीवियस ईयर क्वेश्चन इसरो एग्ज़ाम में पूछे गए हैं वो हम देख रहे हैं। तो ऑलरेडी मैंने 2017 एंड 2016 का वीडियो ऑलरेडी अपलोड कर दिया है, आप ज़रूर उसे देखें। आप वो वीडियो प्लेलिस्ट में जाके ढूंढ सकते हो। अभी हम ये वीडियो सीरीज़ का जो इसरो 2015 में क्वेश्चन पूछे गए थे वो हम ये वीडियो सीरीज़ में देखने जा रहे हैं। तो चलिए बिना देरी किए मैं आपका एक बार फिर से हैप्पी लर्निंग अवर्स में स्वागत करता हूँ। फर्स्ट क्वेश्चन इज thermosetting plastic have in general. So options given are molecular chains that slip past one. Option B, be a ceramic since all the ceramics are glass and glass is a kind of ceramic. Option C is have monolithic crystal structure, and option D have no long range crystalline lattice structure. So basically I think you can easily avoid A and B. Now the confusion exists between C and D. Now if you compare a thermoplastic and thermoset plastic, the major difference is thermoplastics at room temperature they are solid, while if you heat thermoplastic they will turn into a liquid, while in case of thermoset plastic at room temperature they will be in liquid state. If you heat it they becomes hard. So in general thermoplastics they have the linear structure, while thermoset plastic they have the cyclic structure. So for this question the correct answer will be option number D, that the thermoset plastic have no long range crystalline lattice structure. Okay, then question number 2 is silicon steel is widely used in. So options were cutting tool, die and punch, electrical industry and chemical industry. Now basically silicon steel is also called as electrical steel due to its good electrical properties. So basically silicon steel consists of around 6.5% of steel, and basically it is used in transformer. So the correct answer for the question number 2 is electrical industry. Then question number 3 is an eutectoid steel consists of. Now eutectoid steel means a steel with 0.8 percentage of carbon, and such type of steel consists of whole pearlite phase. It's a very easy question. Then question number 4 says a German silver contains. The options were 12.5 percentage of silver, 5 percentage of silver, 1 percentage of silver, and none of these above. Now basically a German silver is an alloy of copper, zinc and nickel. Now due to its appearance, now the appearance of German silver is like a silver. Okay, it's a silver like structure. So that's why the name is given as German silver. So basically German silver does not contain any percentage of silver. So the correct answer for the question number 4 is none of these. Okay, so hope you have understood these questions. These are the easy questions which have been previously asked in ISRO 2015. So let us see next set of question. Now the first question, it is asked in ISRO 2014. The question is aluminum crystal structure is. Okay, so aluminum crystal structure is FCC. It's a face centered cubic crystal structure. Now such type of question is a memory based question. There is no logic behind it. You have to remember that aluminum, it has FCC crystal structure. Then next, now only one question I have found in ISRO 2014 related to material science. The next question is, let us see which questions have been asked in ISRO 2013. Now the first question, the essential ingredient of any hardened steel is. Now the essential ingredient of any hardened steel, we know it's a martensite. Okay, martensite, it's the hardest phase. So the hardness of steel. So let's say you have heated steel, and if you go for a very rapid quenching, very fast cooling, then chances that martensite phase may form. Such type of steel, it has a very good hardness. Okay, next question number 2 says following is the process which is used to form powder metal to shape is. Now basically it's a question based on powder metallurgy. So options were sintering, explosive compacting, isostatic molding, all of this. So basically all these processes, that is the sintering, then explosive compacting and isostatic molding, these are all a powder metallurgical process. So correct answer for this will be all of these. Then next question is one of the characteristic of polymerase. So options were high temperature stability, high mechanical strength, high elongation and low hardness. So it's a very easy question. So polymer, whenever you say the polymer, it has a high elongation. So let us see the next question. Now the question says usually materials with following crystal structure fail in ductile mode is. Now just now we have seen the aluminium, copper, they are having a FCC structure. Okay, if you consider a ferrite, it has a BCC structure. Now a ductile mode failure. Now basically whenever a ductile material, when it goes for an extensive plastic deformation, it fails by a ductile failure. It's a ductile mode of failure. So a crystal structure which exists basically in more ductile material, it is going to fail by a ductile failure. Now just now we have seen previously that aluminium or copper, it has a FCC structure, while ferrite, it has a BCC structure. Now aluminium and copper, they are more ductile, so the chances of ductile mode failure is more in case of aluminium, which is having a FCC structure. So basically the correct answer for question number 4, it will be FCC. It will be FCC. Okay, so the correct answer here it will be FCC. Now the explanation for this question can be based on a slip plane, movement of slip plane. In case of FCC, the slip plane movement is easy, that's why they fail more of by ductile failure, while in case of BCC, if you consider at lower temperature, the movement of slip plane, dislocation movement is less. But if you go on heating the BCC type of structure, then the movement of slip location is easy. So at higher temperature, even BCC can fail by ductile mode of failure, but nothing is mentioned about temperature. So the correct answer for the question number 4, it will be FCC. That is the option number A. This will be the correct answer. Then last question, it is related to work hardening, that work hardening strengthens an alloy by. The options were removing the internal defects in a crystal structure, increasing the dislocation density, decreasing the grain size of the alloy, and the option number D is increasing the lattice resistance to dislocation motion. Now let us understand first what is mean by the work hardening. So basically work hardening is also called as strain hardening. So by arresting the strain in a material, hardness of the material can be improved, which is known as a strain hardening processes. So basically there are 4 types of strain hardening processes. One is a control of grain size, you can control the grain size. Then cold working is one type of strain hardening process. Then solid solution hardening and precipitation hardening. So basically these are the strengthening mechanism. These are the strain hardening or strengthening mechanism. Now if you consider a cold working process and a hot working process, you will find that when a metal is worked at higher temperature, let's say above recrystallization temperature, then the movement of atom is more, so which implies high strain is produced, so hardness will be lower, right? Now if you consider a cold working processes, that is the metal working carried out less at lower temperature, that is at less than recrystallization temperature, then the displacement of atomic plane is difficult, that we can say slip is less, that means yield stress will increase. Okay, and if material is hot work, displacement of atomic plane is easy, slip is more and yield stress decreases. So work hardening strengthens an alloy by increasing the dislocation density. This will be the correct answer for question number 5. So basically If you observe the questions, these are more of basic. If your basics are clear, then only you can tackle with such type of questions. Okay, so let us end this video here. We will again meet with the new video in continuation with the previous year questions of material science or metallurgy, which has been asked in ISRO exam. So thank you for this video. If you are liking my video, please do like and share, and still if you have not subscribed to my channel, please do subscribe. Definitely you will get a very nice videos which will be helpful for your preparation. So once again, thank you and Jai Hind.